Hello. It is always exciting to look back at the beginnings of history from the vantage point of the present. From the earliest inscriptions on rocks by our distant ancestors to the digital encryptions of our times. That is a range, the span of the ascendancy of mankind. But as we look back, there are also unsettling signs. We are prone to disasters of our own making. The discordance with nature, the racial and social tensions, these are also part of our legacy to ourselves. It has been man's passion to tell tales of yesteryears, and in the process, there have been numerous representations. The question naturally arises, if there have been so many representations, what is the need for yet another visual representation? Now, as we know, every story, every idea has a perspective, an ideological orientation, if you like, and the history of science is no exception. All the major historical texts or archives that we are subject to or we refer to have been written from a European perspective, and thus the idea of a European dominance is embedded in them. This series, Manavodayam, is an attempt at telling our story in our own perspective or an Indian perspective. In other words, in creating a niche for ourselves, but by bringing that perspective to the touchstone of objective, verifiable science. Manavodayam was originally a very successful audio series which ran throughout the country on All India Radio. We now seek to recreate that series in visual terms for you, and we hope that the unraveling of the story of evolution in this series will enable you to take a fresh look at our historic and scientific knowledge. The Shukla Yajurveda says, that which is complete arises from completeness. If the complete is taken from that which is complete, that which remains is complete. Try and figure that out. Well, it all began with a Big Bang, the story of the universe. And ever since, it has been a continuous process of Big Bangs, expansions, and diffusions into nothingness. But man has always been lured to the boundaries of that untraveled universe, whose margins keep receding as we move forward.
The clear, moonless, star-studded sky. It evokes in us a sense of wonder and awe, even a sense of the mysterious. sun defines our day and also our sense of time. Once the hunter-gatherer evolved into a settled man, it became necessary to invent methods to mark time. Structures like Stonehenge were once used to track the sun. And then came calendars based on the movements of the sun or moon. These calendars help man anticipate seasons. The agricultural man depended on these calendars to carry out his seasonal chores. The sun sustains life on earth. Every morning it rises in the east and in the evening sets in the west. It is the most important object in the sky for us. We know that it is a star and we are one of its planets. But what is the sun? How far and how big is it? Would it last forever? What is the source of its energy? The sun is merely one of the millions of stars that populate our universe. It is not even the brightest. It happens to be the closest to us. Light takes about 8 minutes or so to travel from the sun to the earth. Light from the next closest star takes about 4 years to cover the distance. Because of its nearness, we could study the sun in detail and hence could understand a few things about stars in general. Sun is a white, hot, glowing sphere of gas. Its surface is relatively cool at 6,000 degree absolute compared to its core at 14 million degrees or so. It is basically a nuclear reactor in which hydrogen burns to transmute into helium. In this process, matter gets converted to energy. Only a tiny portion of this energy that is released reaches our Earth. And every second our sun is losing around 4 million tons of mass. This cannot, of course, go on forever. In about 5,000 to 6,000 million years, all the hydrogen in the core would have burned to become helium. The core would then contract, triggering helium burning. And the exterior of the sun will start expanding and cooling. It might expand so much as to become a red giant and even engulf the Earth. Eventually, the sun would trigger its last round of nuclear reactions, shrinking the core and throwing off the outer shell of materials. the core will cool to become a white dwarf, an object so dense that a spoonful of it would weigh hundreds of tons. All stars do not end up as white dwarfs. It was the Indian-born scientist, Dr. S. Chandrasekhar, who found out that any star 40% more massive than the Sun would not be stable. Massive stars become neutron stars and black holes. A neutron star is formed by the sudden implosion of its core, accompanied by an explosion of the outer shell of materials, resulting in a spectacular display called supernova. Very massive stars eventually end up as black holes, so named aptly by John Wheeler. Nothing can overcome the gravitational pull of black holes, not even light rays. That is why they cannot be seen. Their presence can be inferred only through indirect means. The study of black holes is one of the most fascinating subjects in science today. And the probe goes on. To our ancestors, the Earth looked flat and stationary. They conceived that our universe is a stationary Earth surrounded by a crystal sphere. The sphere moves around to make day and night. The Indian astronomer Aryabhatta was one of the earliest to suggest that the Earth moves. Around 100 AD, the Greek astronomer Ptolemy proposed that the Earth is surrounded by 8 concentric spheres, one each for sun, moon, and stars, and the rest for 5 known planets of that time. The retrograde motions of planets were accounted for by epicycles. The Sun is the center, and all planets circle around it was the model proposed by Polish astronomer Copernicus. He was followed by Tycho Brahe, who made a detailed study of celestial objects and their position in the sky. And German astronomer Kepler worked on the observation of Tycho Brahe, and from it derived the laws that govern the movements of planets. And combined with the work of the Italian legend Galileo, this led to the consolidation of heliocentric model. And then God said, "Let Newton be," and all was light. His theory of gravitation, combined with his laws of motion and calculus, explained almost all the known astronomical observations of that time, and more. To see beyond what our eye can see, one needs telescopes. It was Galileo who first used telescopes to look at the skies. He worked with refracting telescopes. Reflecting telescopes were invented by Newton. From then on, telescopes grew in size as well as in resolution, from handheld versions to huge sophisticated systems housed in large observatories. A modern version of the optical telescope in India is the Vayana Bapu telescope in Kabalur in Tamil Nadu. We can only see a few thousands of stars with our naked eye. Telescopes extend our vision. Today we know that there are millions and millions of stars and galaxies. Galaxies are the building blocks of our universe. Each galaxy comprises billions of stars held together by gravitation. And galaxies are separated by immense distances. Our galaxy is called the Milky Way. We see it only as a band of light across the skies, since we are right inside it. But it has a regular structure and shape. It is disc-shaped from the sides, with a length about 100,000 light years across, and the width in the center is 20,000 light years. Our Sun lies at a distance about 32,000 light years from the galactic center. It is a spiral-shaped galaxy, and our position is just off the Orion arm, one of the arms of the spiral, and nucleus lies beyond Sagittarius. A galaxy rotates about its nucleus. Our Sun takes about 200 million years for one rotation. There are about 100 million galaxies. They occur in groups with large space in between them. The galaxy Andromeda, the deepest object in space visible to the naked eye, is at a distance of 2 million light years. The small galaxy pair, Magellanic Clouds, are the nearest to us, at a distance of 17,000 light years. Our own galaxy forms a part of this group of galaxies known as local group. There are about 20 to 30 galaxies in it, including Andromeda and Magellanic Clouds. And with innumerable groups and clusters of galaxies, one can perhaps visualize our universe as an enormous sponge in which galaxies are arranged like filaments and sheets around huge empty spaces. And we are a tiny particle in one corner of a minor galaxy, a small planet revolving around an ordinary star. The development in modern physics gave a new thrust to studies of cosmos. Instruments like spectrograph helped the analysis of light coming from various sources in space. This led to a better understanding of the physical process taking place in stars and other celestial objects. But light is only the visible part of a vast spectrum of radiation known as electromagnetic radiation, which includes radio waves, X-rays, and so on. And radio telescopes, combined with modern techniques of data processing, help us look beyond the visible range. The giant meter-wave radio telescope at Pune, the world's largest array of meter-wave telescope, is India's contribution in this field. Has this universe a beginning? If so, when? Questions like these have been agitating the minds of men since ancient times. Today, most scientists agree that there was a beginning. The intellectual adventure that led to this answer can be traced to the general theory of relativity proposed by Albert Einstein in 1915. He found a mathematical solution that implied the existence of a non-static universe. And the Russian cosmologist Alexander Fredman worked out in detail a model of a universe that is expanding. Observation and studies of scientists like Slipher and Hubble in the beginning of the 20th century confirmed that galaxies are expanding, moving away from each other. Meanwhile, Georges Lemaitre of Belgium proposed an idea which later became known as the Big Bang Theory. That the universe we see today is a result of an explosion of a single primeval atom. The Big Bang idea was not acceptable to scientists like Fred Hoyle, Hermann Bondi, and Giant Nadliker. They felt that the universe had always been the way it is now. That is, an unchanging, steady state. But the evidence in support of Big Bang Theory kept growing. Gamow in 1948 predicted that radiation from the very hot early universe should still be around today in the form of microwaves. And lo and behold, Arno Penzias and Bob Wilson found this remnant radiation in 1965. This is as good a confirmation of the Big Bang Theory as any scientific theory could hope for. Today, most of the cosmologists believe in the Big Bang Theory. And the plausible scenario of events following the Big Bang that occurred 15,000 to 20,000 million years ago can now be visualized. On a day without yesterday. Within a millionth of a second of the explosion, particles like protons and neutrons are formed. After about 100 seconds, the temperature falls to 1 billion degrees and soon hydrogen and helium nuclei come into being. Within a few hours, the production of helium and other elements stop. $300 million years later, stars and galaxies form. In 1993, Fred Hoyle and Narlika proposed a new model called the quasi-steady state theory.
Fred Hoyle, Jeffrey Burbidge, and I, we are working on a cosmological model in which the universe has had no beginning, but in which matter is created from time to time in little explosions, which we call mini bangs. So instead of one big bang, we have a continuous series of mini bangs which produce matter into the universe. And in the process of production of matter, the new matter pushes out the old matter, and therefore there is an expansion of space. And this is the reason we argue that the universe is seen to be expanding.
We are part of a planetary system of a very ordinary star on one tiny corner of this universe. And we call our place the solar system. Our solar system is only about 4,000 to 5,000 million years old, formed from the remnants of other stellar systems. The process is like the formation of any other star planetary system. A cloud of interstellar dust of glowing gas collapses to form a flattened disk. The interstellar dust and the periphery stick together and form planets, and the center becomes the star we call Sun. And in this solar system, we have our abode on a planet called the Earth, with a delicately balanced ecosystem that supports life in myriad forms, including man.
From the universe to planet Earth seems almost to move from the sublime to the ridiculous, especially the way the Earth is. But the Earth is our immediate universe. So join us on planet Earth in our next episode.